A give me an answer, B give me an answer. Both answers may be wrong, but the interviewer can judge which one has a better concept or better intelligence. So this is a good question, if we can do this. In our course, I will try to ask you some questions for you to think about. But always, you remember, if you have this in mind, engineer always try to reduce the cost, then it will be easier for you to think of the answer, or good answer. It may not be 100% correct, but at least you can show the interviewer you have some sense. Okay? I will try to ask you some questions in our course. So this topic also, we always try to reduce the cost. It is always like that. If, no matter you are electrical engineer, mechanical engineer, it is always like that. You try to minimize the cost, but you have to satisfy certain rules, certain conditions. Okay? Just like the air. We concern about the voltage drop. For a distribution supply, of course, we want to use the conductor as small as possible because it saves the money, especially if you are the contractor, right? You want to use a very mini size or micro size cable. But in this case, you may fail to satisfy the requirement. So our job is to minimize the cost, but subject to satisfying all the requirements. The requirements are stated in the supply rule, the requirements set in the IEE regulation. We satisfy them, but minimize our cost. Then we have done our good job. So here is we consider the voltage drop. Suppose our socket is 220 volts. We will not expect the voltage drop to, let's say, 200 volts. Okay, it may affect the performance of our air conditioner, for example, because our air conditioner is designed at 220 volts. It has the maximum efficiency at that point. If you only supply it at 200 volts, it can work, but not at the optimum efficiency, optimum condition. So there are certain requirements. The voltage should not exceed a certain limit. In IEE regulation, usually it should not exceed 4% of the nominal value. The voltage cannot lower than 4%. So in this case, our design, we will consider the voltage drop should not exceed 4%, for example. So here is one simple calculation here. In this arrangement, we have for example, this symbol stands for circuit breaker. Okay, cross circuit breaker. Supply bus bar. From this bus bar, we have several meters or circuit. Okay, in this circuit, we have to consider the voltage drop. For example, 4% of the nominal voltage. Okay, so this is the voltage drop here. Is just equal to using Ohm's law. It's just current times resistance. So I1 is the current flowing here times the resistance. Resistance is equal to rho. Rho is the resistivity. Okay, resistivity times length of the cable divided by the area A of the cable. Then that is our resistance. I times R is the voltage drop. So it may be equal to 4%, let's say. For this circuit also, okay, and also for secondary. And then we can calculate the cross-section area A1, A2, A3. Suppose 4% is our limit, so we can, in this case, we can find the value for our design, okay, to satisfy this requirement. What are the cross-section area? And then we can find the total volume of conducting material. That is proportional to money, right? The material volume, that is proportional to money, is equal to the volume of the conductor we use.